Welcome to question 8 of the 2017 Mathematical Methods Exam 1 for the Southern Hemisphere. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAR. So for question 8 we have events A and B from a sample space. We have probability of A given B occurring is 1/5 and the probability of B given A has occurred is equal to 1/4. And we're going to let the probability of A intersecting B equal P. For part A, we're asked to find the probability of A in terms of P. So for this question, we're going to be dealing with conditional probability quite a bit. So from our formula sheets, we can recall that the probability of A given B has occurred is equal to the intersection of A and B, so the probability of A intersecting B, divided by the condition, so that is the second event listed here, which will be the probability of event B occurring. So with that in mind, we want to find the probability event A has occurred. So in our conditional probability, we actually want the probability of event A occurring down the bottom, which means we will need A in this position, and overall the piece of information that's going to be most useful to work with is the probability of B given A has occurred. So we're going to start with that piece of information for the question. So we know that the probability of B occurring given A has already occurred is equal to the probability of A intersecting B divided by the probability of the condition A. And from the information given in the question, we know that the probability of B occurring given A has occurred is 1/4. So that's going to equal the probability of A intersecting B, but the probability of A intersecting B is simply P. So that's going to be P divided by the probability of A. And now that is what we want to solve for, so we've got to get that by itself. So multiplying both sides by the probability of A, we get the probability of A divided by 4 is equal to P. And then multiplying both sides by 4, we get the probability of A in terms of P is simply 4P. So that is the answer to part A of this question. From the examiner's report, we can see that 73% of students got this correct, and that the examiner goes on to state that this question was generally well answered. The most common errors included solving for the probability of B rather than the probability of A, and incorrectly transposing P on the probability of A to give 1/4 instead of 4P. So we have the same information, but for part B, this time we're asked to find the probability of the complement of A intersecting the complement of B in terms of P. So whenever we're asked to find an intersection, you can use a Venn diagram or a probability table, and they are two really efficient ways of tackling these sorts of questions. So my preference is generally to use the table, so I'm going to set up event A and A complement, B and B complement, and we know with such a table that the sum of the probabilities down this column or across this row would equal 1. And now we need to put as much information into this table as we can. So we know the probability of A intersecting B was simply P, so A intersecting B is this cell here. And on the previous slide we also found the probability of A occurring was 4P. And now using similar logic to what we did for part A, we can find the probability of B occurring. And to do that, we're going to this time use this piece of information. That is, the probability of A occurring given B has occurred is 1/5. So the probability of A occurring given B has occurred can be written as the probability of A intersecting B divided by the condition, which is the probability of B. And we know from the question that that was equal to 1/5. So 1/5 is equal to probability of A intersecting B, well that's P, on the probability of B occurring. So therefore the probability of B occurring is equal to 5P. So we can now add that to our table up here. And now the great thing about using a probability table is we know that we simply add this cell and this cell to get the 5P, and we add this cell and this cell to get 4P. So that means this can be written as 4P, because P plus 4P equals 5P, and this can be written as 3P, because P plus 3P equals 4P. And now if we were to add something to 4p, we would get 1. So this must be 1 subtract 4p. And by similar logic, this is 1 subtract 5p. And now at this point, the probability of A complement intersecting B complement is this cell here. And once again, we know that if we add across this row, we get to 1 subtract 5p. So that allows us to make the statement that 3p plus the probability that we're after, which is the probability of A complement intersecting B complement, is simply going to equal 1 subtract 5p. And then if we subtract 3p from both sides, we get the probability of A complement intersecting B complement is equal to 1 subtract 8p. So that is the answer to part B of this question. So from the examiner's report, we can see that just a touch over a third of students got full marks for this question, with a large number of students getting 0 marks for the question. So students who scored highly usually used a table or a Venn diagram to arrive at their answer. And the examiner noted that there were various misconceptions of the connection between conditional probabilities and the probability of A complement intersecting B complement. Many students assumed that events A and B were independent, hence incorrectly using probability of A complement intersecting B complement is equal to the two probabilities multiplied together. However, you're not allowed to assume that two events are independent unless it's stated or it's a very reasonable assumption to make. And in a question like this simply isn't a reasonable question to assume that independence is the relationship between those two events. For part C, we have given that the probability of A union B is less than or equal to a fifth, state the largest possible interval for P. So the probability of A union B, we have a formula for that on the formula sheet, and that is that the probability of A union B is equal to the probability of event A occurring plus the probability of event B occurring minus the probability of their intersection, A intersection B. So therefore, for this question, we have the probability of A union B is equal to the probability of A, which we previously found to be 4p, plus the probability of B, which we previously found to be 5p, minus their intersection, which is just p. So overall, that is equal to 8p for the probability of A union B. The next thing we know is that the probability of A union B is less than or equal to a fifth. So therefore, 8p must be less than or equal to 1/5. And now dividing by 8 to get p by itself, we find that p is less than or equal to 1/40. However, that's not quite the final answer that we need. So before we go and state our final answer, we just need to think back to the start of the question, where we had the probability of A given B has occurred was a fifth, and the probability of B occurring given A has occurred is a quarter. And what that information tells us is that the intersections are non-zero. So those two values are non-zero, which implies that the probability of A intersecting B cannot equal 0, and A intersecting B was P, so we know that P cannot equal 0. So we know that P cannot equal 0, so therefore P must be an element of 0 not included, and we said that P could be any number less than 1/40, but obviously not a negative number because we're talking about a probability. So 0 not included up until 1/40 included. So that is the largest possible interval for P and the answer to this question. So from the examiner's report, we can see that only 10% of students got that fully correct, although most students identified that the probability of A union B was 8p. However, only a few students identified the correct interval because they did not consider the case that P could not equal 0. Common incorrect answers included P equals 1/40 or P is less than or equal to 1/40, but that second incorrect response there actually allows for negative probabilities, which is not possible. And the last common incorrect response included 0, and based on our discussion on the previous slide, we know that 0 needed to be excluded.